Okay, so chapter 2, section 6, prove statements about segments and angles. So what we're doing today is our actual proofs. We are in actual proofs now. So again, this can be the most frustrating thing for a lot of students. And I say that not because I want you to be frustrated. I say that so that you understand that this is the hard stuff, so this is where you want to focus your attention here and go, okay, well, if everything else, if I was a little off today, at least make sure I pay attention to this, because you don't want to fall behind on it. It's hard to catch up from here. Okay, so we're going to talk about a two-column proof. A two-column proof literally has two columns. If you look below, you see that there are two columns. It kind of looks like a chart. And a proof is just a logical argument that shows a statement is true. I am going to prove that something is true using given information. This is not the only type of proof. There are flowcharts, there are paragraphs. If you are the kind of person who loves math and you want to get deep in it, you want to you want your degree in mathematics, then this is the kind of thing that you will be doing going on. It has a two-column format where the statements are on the left. Here are the things that I'm saying, and the reasons on the right, meaning this is the reason why this happens. Why can I say that? I'll tell you on the right. On the left are the things that here's how I am logically going through my argument. It says, given info or the result of applying a known property or fact. And on the right will always be our explanations. Why can I do that? Why is that allowed? I know this is going to take a minute to catch up, so I'm going to pause right here. Okay, so here are the acceptable reasons in a proof. That's the right-hand side. We're talking about let me just make a note here that this is the right-hand side. Reasons why you're allowed to do stuff. So you are allowed on the right to say that I can say this because that was given to me. So given is a very important word, meaning that I have to give you something, right? I can't give you a problem on a test and not tell you any information and just expect you to come up with some answers. I need to give you some information, and from that you can work through it however you need to. So you can use definitions of things. For example, let's say the definition of two things being congruent. Like if I say that two triangles are congruent. What do I mean just in plain English? What's the definition of that? They're equal. But not just equal, they're same what? Same two words. Same this and same that.
Same angles and same size.
So same shape and same size. So that's the definition of congruency. Properties, the properties of equality, the postulates that we've learned, those are all going to be things that we can write on the right. Or theorems, as long as we have already proven that this theorem applies in a certain case. We have to be okay, well, let me show you that this theorem can be used here. So don't stress this in the beginning if you don't get it, but these are the things that we can use on the right. These are the things that back up, because if I look at the left and say, wait a minute, why can you say that these two things are congruent to each other? You will state that on the right-hand side. Yes, ma'am?
So what does it mean by properties?
Properties of equality, substitution, subtraction, all those things that we just learned yesterday. Yes, ma'am?
So when you say right-hand side?
The right column.
Like in the chart?
Yes, yeah. The left column is where we're making statements, where we're saying this is true. On the right, back it up. If I say, I'm a hockey fan, so I realize most people don't like hockey. If I say the Colorado Avalanche are the best team in the world, then I better come up with some information to back it up, and that's my right-hand side there. Okay, you say that, then back it up. Why? You know what I mean? You need some reason as to why. Okay, so we've got three properties here that we're going to be able to use in addition. Now, the reflexive property, now I teach this in a very weird way here because I'm going to teach it and I'm not even going to use the same word here. If you notice, there's something about this property where something is congruent to itself. Line segment DE is congruent to line segment DE. Or angle D is congruent to angle D. Something is congruent to itself. That makes sense, right? If I said my own height is congruent to my own height, that may seem like a very silly statement, but you would all agree with that, right? My height is exactly the same as my height. Whether or not you're that's just a dumb statement to make, it's true. It's a true statement, and you'll see why actually this saves our butts so many times in geometry. Things that aren't they don't seem like they're real brilliant or anything like that, but they help us out. Now, the way that I remember this one is the word reflexive sounds a lot like reflective. So it doesn't, now don't write reflective, it's not reflective. But it's kind of like a mirror, right? And when I look in the mirror, I see me. When you look in the mirror, you see whatever, you see you. Like anyone looking in the mirror sees themselves. So it's almost like a mirror that DE sees DE there. It's on the other side, it's the exact same thing. Now the symmetric property is just like the reflexive property, except it's the reverse order here. And you've used this many times before. Notice they said that if line segment DE is congruent to line segment FG, then line segment FG is congruent to line segment DE. So just in plain English there, what happened? Like what happened? We don't need to math it out. Just in plain English, what happened? Yes, ma'am.
You swap sides?
They swap sides. And whether you know it or not, you've done this before because you've gotten to a situation like this, right? We've all been there before. But sometimes we decide to do what as the next step? We flip it over. We change it, right? We go, okay, well then this is true too. So we're just changing the order there. Like what we're doing is that if these two things are equal to each other, it doesn't matter which one's on which side. They're equal to each other. My money is equal to your money. Your money is equal to my money. They're all like the same. Doesn't matter which one is on each side. It's just an example. And it works with angles and it works with segments too. If angle A is congruent to angle B, then angle B is congruent to angle A. Now, transitive property is one that is just like syllogism. It's just like syllogism. Notice here, and I say that because I'm sure you're going to get what I mean when I say it's just like syllogism. If line segment AB is congruent to line segment CD, meaning those two things are equal to each other, and line segment CD is congruent to line segment EF, then doesn't it mean if this is the same as this, and this is the same as that the first thing must be congruent to the last thing? If all those things are the same, then it must be the same. They all have the same. For example, if I say, I have the same position as Mrs. Corey, and Mrs. Corey has the same position as Mrs. Boyd. We're all teachers, right? I'm a teacher, she's a teacher, and she shares the same position with Mrs. Boyd. Well, then it must mean that me and Mrs. Boyd also share the same position because they're all equal. So you can bring things together through that common friend. And when we do that, not using logic, but when we do it in a proof, we are joining things together to be able to say the first thing is congruent to the last thing. And that is the transitive property. We're moving from the first all the way to the last. So it's the one that's the closest way I can describe it is like syllogism. The first is equal to the second, and the second is equal to the third. Therefore, the first and the third have to be equal as well. All right, proof time. I'm going to go real slow here, and you should pay real close attention here because this, what you're looking at, is, I'm not saying that this is the question on there. I'm saying this is just like how I will give the question on here, that you should know that you go, okay, here's the kind of thing he's going to give me, and he's going to expect me to fill in everything on the right-hand side. So I'm just going to give myself some little lines here just so I can separate them here, that there's going to be my first reason, my second reason, my third reason, my fourth reason, and my fifth reason. Okay, a proof will always have these two things. If you look up top, there is a given, something that I'm giving you, and you know that to be true. It is a guarantee to be true because it was given to you. And the last thing, which you are trying to prove. That is what you are trying to get to. That is your ultimate goal. Now, if you notice, this will be true for every single proof. The first thing here will always be the first thing there. And the thing you're trying to prove will always be the last thing. Always. Every single time in a proof. What did you give me and where am I trying to get to? Because my last step, once I get there, then I'm done. Okay, so notice on the left, there's the first statement. We have to go through this in sequential order. We cannot skip down to something or it's not going to make sense. The first one is that the measure of angle 1 is equal to the measure of angle 3. Why is it that I am allowed to say that? Yes, ma'am. It was given. So that's all I need to write is given. That is the information that was given to you. You should never get a 0 on a proof Because I'll tell you what, the very first one is always given. I have to start with what information did you give me? Right? You start a problem looking at what did you give me, and then I'll see where I can go. So, you know what? Like, you could be like, I didn't know anything, but I at least got 1 point for writing given. Okay, that's something. Know that. Like, know that. No more than that, but if not, then just that. Now we get to the part where we have to work. They're making a statement. Here's what they're saying. They are saying that the measure of angle EBA, let me find EBA up here, EBA. They're saying that that angle is equal to the measure of angle 3 plus the measure of angle 2. Why is that true?
Is it the angle addition postulate?
It is the angle addition postulate. Remember, if you look at it, there's that piece of cake right there, and it's broken into two pieces, angle 2 and angle 3. So the angle addition postulate. Nice work. Now, if you notice, lines 2 and 3 are ridiculously similar. They are so close to each other. But something has changed. What has changed between line 2 and line 3? Yes, ma'am.
And angle 1, like angle 1.
The measure of angle 3 on line 2 turns into the measure of angle 1. And the question is, how the heck did that happen? Why are we allowed to do that? Yes, ma'am. Substitution. Because look, here on the first line, we said it's okay to substitute them. That is okay to do. So this is substitution.
Is it just substitution?
It's the substitution property of equality, but most of the time, a lot of people are just okay with substitution. We sub something in. We sub something in. Just don't write the word sub, because here's the problem with the word sub. It could mean subtraction, and it could mean, I'm usually even very forgiving if somebody writes subtraction. But when you just write sub, there's nothing I can do, because that could be two different things. Subtraction and substitution are two totally different things. Yes, ma'am.
How come 3 could it be angle addition postulate?
For this one?
Yeah.
Because if I look at angle AB, look, so it says that angle 1 plus angle 2 equals EBA. I can't see that in the picture. EBA looks like 2 and 3. So really what we did there is we said here was definitely angle addition postulate, but then really the only thing, look how it's changed. Really, each line I look at how it's changed. Here's EBA, here's EBA. Here's angle 2, here's angle 2. The only thing that's changed is right there. And so the question is, how did 3 become 1? And I have to look at it like, go back and go, oh, wait. So using the given information, they substituted in. They pulled one out and put something else in. That's substitution. All right. Now, they're going to say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle DBC. So let's find out where DBC is, just so we know what we're talking about. DBC is that angle there. And they're making the statement that that is equal to the measure of angle 1 plus the measure of angle 2. How? Colette? That is still the angle addition postulate. We're coming back to that. Because if you look in that blue area there now, I see that 1 and 2 are the angles that make up the big blue angle. So that's the angle addition postulate. Yes, ma'am.
So, well, we're basically ignoring the fact that they swapped the sides and swapped the angles. Because it went from angle EVA to angle GBC.
Well, the thing is that here's what I might have done is I might go like this. I might go, well, look, 1 and 2 stayed the same, but how did EBA become DBC? And I couldn't think of a logical reason why that would happen. So I also looked at it, I go, well, okay, well, let me find angle DBC, because they just introduced that. That was a new thing. That's the first time I've heard DBC. So I'm going to go, well, wait, where did that come from? How is it possible they're saying it? So I went to the diagram and looked at DBC, and now I can see that it's made of 1 and 2. So that's why, is because we brought in this new factor, well then, okay, like now we're going to look at the last line and say, how did we get from line 4 to line 5? Notice that something has changed from line 4 to line 5, and our job is to justify why did it change. Yes, ma'am.
Substitution.
Ooh, talk to me about why it's substitution. Okay, so what stayed the same between angle 4 and angle 5? Line 4 and line 5. What thing stayed exactly the same? DBC is still there. That didn't change. But the angle 1 plus angle 2 became EBA.
On statement 3, you already know that they're equal to each other, so you can just substitute it.
Fantastic. On line number 3, we have already proven that this is true, that angle 1 and angle 2 can be swapped out with EB8 anytime it works to our advantage, and that's exactly what happened there. That's just substitution. And now if you notice, we've gotten exactly to where we said we would get to, is the measure of angle EBA is equal to the measure of angle DBC. That is exactly what you will be expected to do come Tuesday. I don't think that's easy. I'm not even joking there. I don't think it's easy. It takes a lot of practice. Now I'm going to tell you how you're going to practice with it in a bit. But right now, I'm going to leave that for just a second to get copied down, and then we're going to move on to some others. We still have one more proof I want to work on today, and time is ticking, so I got to move a little bit faster. All right, another proof. Is it likely that I'm going to use angle addition postulate anywhere in here? No, what it would be more likely that I'm going to use? This segment, if I'm going to, now I'm not saying it's in there. I'm just saying that, okay, let's get away from angle addition postulate because these aren't angles. These are segments. So here's what we're doing. The given, which is right here, that's what they gave to us, and what we're trying to prove. If you notice, just as I said, here's my first line, here is my last line. That will always be true. So even if you stink at these and you're like, man, I will never get that to save my life, what should be the very first reason? Given. So at least get those points. 1 point is 1 point. Now, here's where we go from there. We've got AB plus BC equals AC. AB plus BC equals AC. Essentially what they're saying is that AB plus BC is equal to AC. What is that? That is the segment addition postulate. Segment addition postulate. The first part plus the second part equals the whole thing. Yes, ma'am.
So I thought we were doing of how 1 changed to 2, not what.
Well, sometimes here's the thing is that when I say how 1 changed to 2, like you can do that too. You can say, well, this stayed the same and this stayed the same, but how did AB plus AB become AB plus BC? You might want to say substitution, but I don't have anything anywhere that said that I was allowed to swap this for that. Nothing said that anywhere. When you do a substitution, it has to be because it's already been cleared. The problem said it's okay to do that. You can't just substitute because you want to. You have to substitute in with things that you know that are okay to do. In this case, I didn't have any information that allowed me to do anything except for going, why was it that AB plus BC is equal to AC? All right, so now we are going to take a look at what we've got here. We've got AB plus AB is equal to AB plus BC. Colette, talk to me about why it's substitution.
Because in the first line it says that AC is equal to AB plus AB, and then it also says that in the second line it also says that AB plus BC is equal to AC. Does that mean that they're equal?
Perfect. Here's what she's saying. She's saying that, notice on line 2 and line 3, that never changed. That's still there. That didn't change. What happened is somehow that AC turned into an AB plus AB. And she's like, well, how would that happen? And she looks back on the first line and go, hey, you know what? You cleared me right away on this first line to anytime I see an AC, I'm allowed to swap it out for AB plus AB. And that has been cleared. That is okay to do. That is substitution. All right, lastly, this stayed the same, this stayed the same, but something has disappeared. AB disappears. How? Subtraction. We subtracted AB from both sides. That's the subtraction property of equality. Usually I'm pretty forgiving if you just wrote subtraction, but again, don't just write sub. I'm not okay with that. Yes, ma'am.
How is that not transitive? Because isn't it?
We'll look at line 3 and line 4. Would you agree that this is true, that this is still right there and this is still right there?
Yeah.
Okay, so what AB plus AB is equal to AB plus BC. So I see what you're doing. Can I address what you're doing in a minute? Because what you're doing, I don't want to confuse people, because actually what you're doing is you're making a tiny mistake there, and if I show it to you, I'm afraid that we'll get Like, I'll go back to that. Save that question. I want to come back to it. I'll show you why it's not transitive in just a moment. Okay, this is what I think is one of the hardest ones. So here's what we've got. Given that M is the midpoint of line segment AB, we need to prove that two things, that AB is equal to 2 times AM and AM is equal to 1/2 AB. Don't stress at all. This is not like I cannot look at these and figure out every single line. I have to go in sequential order. What is the reason that M is the midpoint of AB? It's given. That's your freebie points. Now from there, they're saying, okay, well I know M is the midpoint of this. They're saying that AM, line segment AM is congruent to line segment MB. Why is that true? And take a stab at it. Like, just, even if you're not sure, you're like, logically, why does that make sense? Okay, but so segment, they never said, like, so they're not saying that AM plus MB is equal to AB. That would be the segment addition postulate. They're not making that statement. There's another reason here. Yes, sir?
Because it's congruent.
How do you know they're congruent? Like, you're not wrong, but I need more from this. Like,
Because M bisects the line segment in the middle.
perfect. Here's what he's saying here. Since that is in the midpoint, he knows that this must be true. So that's exactly what we're trying to prove, is that this and this are congruent. So what he's doing there is using, that's a very tiny line. He's using the definition of midpoint. We were told that this was the midpoint. So he used that to infer some meaning and go, okay, well, if that's the midpoint, that means that the piece on the left and the piece on the right are congruent, because that is the definition. And if you remember, things that we're allowed to use for reasons, definition was one of them we were allowed to use. Definition was on that list of things we were allowed to use. Now look at line 2 and line 3. They barely even change. They barely even change. What changed between 2 and 3?
It's an equal sign instead of congruent.
Perfect. It went from congruent to equal. So how did that happen?
Now it's the segment addition postulate.
Okay, well, they're just saying that AM is equal to MB.
Oh.
So notice it's changed, though. Something has changed. It's not just that they've swapped. The reflexive property means that one thing, the thing on the left should be the same as the right. But what does it mean when two things are congruent? Oh, so we know in our heads that when two things are congruent, then it means they're equal. So take a guess as to what I'm going to write on the right-hand side.
Definition of congruent.
Definition of congruency, or just definition of like this. How did I know that? Because that's what congruent means. If you're telling me that these two things are congruent, if I've proven that they're congruent, well, then I can say that I know they're equal. And now some people are going to be very happy with the reason for this one, because they've been just waiting to say this. AM plus MB is equal to AB. Colette. That is the segment addition postulate. That's saying the first piece plus the second piece is equal to the total piece. That is and I'm going to abbreviate here, SAP, just for time's sake. I don't like to abbreviate it, but I have like 5 minutes and I still want to get your quizzes back to you, so I am flying right now. Now, notice that line 4 and line 5 have changed only slightly. There's only a slight change. Yes, sir? What was substituted out and what was put in?
The MB for the AM.
And why were we allowed to do that? What gave us the reason? Which line says that we're allowed to do that?
The definition of congruence.
Well, no, you're on 100%. Like, so he's saying right here that this MB has been swapped out for an AM. Which one of the lines told us that we're allowed to do that? Which line up there said that, hey, you're allowed to do that? Line 2, not line 2. Line 3, that says they're equal to each other. They're equal, so you can swap them out. So that is substitution right there. We are nearing the end now. And this is what I think is one of the harder proofs. So if you're like, oh, this isn't so bad. So how did AM plus AM become 2AM? And just plain words. Right, we combine them. And in math, we call that simplifying. We combine like terms, that's just simplifying. So simplify. That's it. When you're actually doing the adding and subtracting on one side, you're not doing it to both sides. That's not the addition property of equality or anything like that. That's not multiplication, because we're not multiplying by both sides by 2. We're just combining what it says to do. AM plus AM is 2AM. Yes, ma'am?
Would it be acceptable to say combining like terms?
No, because we're going to use the word simplify. So like, what you're doing is combining like terms, but what we're going to call it is simplifying.
Why wouldn't we put an addition property?
Because did you add that to both sides? The property of equality says you have to do it to both sides. We didn't do it to both sides. All we did is do exactly what it said. AM plus AM is 2AM.
So you can't just put addition?
No. So you're simplifying. You're doing all the work on one side there. You're like, if there are numbers, if I said, 5 plus 3 equals 8, well, you add 5 plus 3 together on one side and you go, oh yeah, it's 8. So the question now is, how do I get from line 6A to 6B?
Would be symmetric property?
So think about logically, how did they get there? What did they do? Like, they've done something there. The what? The division. They've divided both sides by 2. That's the division property of equality. I don't mind POE. I don't mind it at all. It's very commonly accepted amongst geometry teachers, property of equality. I'm going to zip through the last one because I do want to get these passed out to you. So real quick, you can read this. This is just about how these are broken down. So this is just a read it. Like, here's how proofs are laid out. The statements are on the left. The reasons are on the right. And now I'm going to hand you back your quizzes.